Hello everyone, in this session we'll be discussing the data hazards in pipelining. So data hazards are the hazards or stalls introduced into the pipeline because of the non-availability of data for execution. So when do they occur? Usually data hazards occur when there is a data dependency between instructions. So here you can see A is calculated as 3 plus A, and this calculated A is immediately used in the next instruction. So only after the previous instruction gets executed and we get the result of A, it can be utilized in the next instruction for calculation. So the next instruction has to wait until the previous instruction completes its execution. Here you can see these two instructions. You have C, but there is no data dependency. But that is, the result is not used as the source operand in the next instruction. So there is no hazard. When two operations depend on each other, they must be sequentially executed in the correct order. For example, so here when you see a low level instruction R2, R3 and R4. R2 is multiplied with R3 and the result is stored in R4. So R4 is the source operand in the next instruction. So there is a data dependency. So you have a data hazard. So here if you see how it gets executed in a pipelined architecture, the multiplication instruction is fetched, decoded, executed and returned. And if you see the add instruction, it will be fetched, decoded and it has to wait until the source operands are ready, and it will be available only at the end of the fourth clock cycle, and only then it decode can complete. So the fifth clock cycle it gets decoded, executed and then returned in the seventh clock cycle. Since a stall is introduced into the pipeline, all the other successive instruction will be delayed. So stalls because of data dependency, and this represents data hazard. So what is the solution for data hazard? So we have three solutions. One is operand forwarding. The second one is introducing no-op instructions. The third one is instructions designed with less side effects. So first we'll see what is operand forwarding. So operand forwarding is immediately when you execute, the results are available in the result buffer. So instead of making the result return into the final register and utilizing for the next instruction, you can forward it through a forwarding part to the CLU. So in the immediately next clock cycle, the next instruction can utilize the result calculated in the previous clock cycle. This process you call it as operand forwarding. The next solution is handling hazards, data hazards in software by introducing no-op instructions. So in the same example, if you see two clock cycles are delayed, so two no-op instructions are introduced into the pipeline. So this will not actually reduce the number of clock cycles, but it will have an effect as if there is no delay. So this will be provided by the compiler. So compiler has to identify the instructions where data hazards are there and use no-op instructions, or it might find out some useful instructions which is independent of the previous instruction and rearrange and give it to the execution. The third solution is to design instructions with less number of side effects. So for example, you can see add instruction and the next instruction is add with carry. So add with carry is dependent on the carry which is generated by the previous add instruction. So even though there is no explicit data dependency as given by the multiplication and addition instruction, this instruction has an implicit dependency, and we have to design instructions where we have implicit dependency so that you can reduce data hazards. So we have to this instruction has a side effect, add instruction has a side effect. So because of that you have an implicit dependency. So we need to design instructions with less side effects. So these are the three solutions for data hazards. Thank you.